Alright, so this is number 5. Let R be the region enclosed by the graphs of g of x and h of x, the y-axis, and the vertical line x equals 2, as shown in the figure above. Find the area of R. Alright, so, first of all, this is going to be an integral of top minus bottom, right? The integral between 0 and 2 of top minus bottom. The tricky part is which one is the top. This is a no calculator question, so we have to do a little bit of thinking. The cosine one, this is a graph of cosine, right? It's centered around -2 with a magnitude of 3. So centered around -2 with a magnitude of 3. That's going to be the bottom one. And so the top one, this is an upside down parabola with a vertex at 1, 6. So 1, 6, that's that one. So essentially, it's h of x minus g of x. So let's get to writing all that stuff down. We have the integral between 0 and 2 of h of x minus g of x dx. Let's fill some stuff in. H of x is 6 minus 2x minus 1 squared, and then minus -2 plus 3 cosine pi over 2x. It really wouldn't hurt to do some simplification here. What can we do? I mean, like, we can... Alright, so 0 and 2. Okay, so 6. This is going to be a plus 2 minus 2x minus 1 squared minus 3 cosine pi over 2x dx. Okay, so I like from here, honestly, I think we're pretty good. Take the antiderivative, we'll have 8x. This will add 1, divide by the new exponent. And then, like, that's an x minus 1, its derivative is x, so it doesn't matter for the chain rule. Minus, okay, so we're going to need chain rule, or inverse chain rule, here again as well. This, we're going to end up multiplying by 2 over pi, essentially, dividing by pi over 2. So that's 3 over pi over 2, or 6 over pi. Sine of 2 pi x, pi over 2. Between 0 and 2. Now we just have to plug in 2 and we have to plug in 0. Okay, let's start all the way over here. Okay, so we have 16 minus 2/3 1 cubed minus 6 over pi times the sine of pi over 2 times 2 times pi minus 0, negative 2/3 times negative 1 to the third minus 6 over pi sine of 0. Alright. 16 minus 2/3 sine of pi is 0 minus plus 2/3 minus 0. $16. I feel like I flipped a negative somewhere in here. Oh yeah, hey, negative, negative, negative. That should be a negative 2/3. All right. That will, yeah. So it's 16 minus 4/3, which is what, 14 2/3. All right. For part B. A region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis has area equal to 1 over x plus 3. Find the volume of the solid. All right. This one is easier than it looks because we're given the area. We don't actually care about the distance in here at all, right? Like for a lot of these, it's a square with height whatever, or it's a rectangle with height whatever, not a square. If it was a square, it would have that same height. So like we don't have to do anything fancy. All we need to do is integrate between 0 and 2 of area, and we'll get volume, right? The integral between 0 and 2 of area is the volume. And we're given the function for area already. So we need to take an antiderivative. This is going to be, so this is the x plus 3 to the negative first. That's the one where the polynomial rule doesn't work on it. So this is natural log. So we have the natural log of 5 minus the natural log of 3. And that honestly is our final answer. For part C, write, but do not evaluate, an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 6. So that's this line right up here. It just touches, it doesn't overlap with that at all. Right, so this is, we're drawing a bunch of washers, right? Let's switch over to there. So each cross section is going to be like this, and the volume, or sorry, the area will equal area of the big one minus the area of the small. In this case, well, yeah, okay. So we have a bunch of circles. So it's going to be pi big R squared minus pi little r squared. In our drawing now, we have to keep in mind which one is the top and which one's the bottom. Just as a, let's see now, this bottom one is G. I cannot write with a mouse, and the top one is F. So this distance is going to be the radius. That distance is going to be the radius. That distance is 6 minus g of x. That distance is 6 minus f of x. All right. If I could draw straight lines, this would be easier to see. But all right, the distance between 6 and 1 is 6 minus 1. The distance between 6 and 5 is 6 minus 5. So let's take a look at that. Alright, so we're having an integral between 0 and 2 again. And it's going to be pi big R squared minus pi little r squared. We could factor the pi's out if we wanted, and let's do that. Pi 0 to 2 r squared minus r squared. Now we just have to find out what the two radiuses are, and that's the 6 minus 6 minus g of x. That was the big one. Oh, whoops, forgot my integral. Squared minus 6 minus f of x squared. And then let's plug the functions in for there. And let's start over here because we have a lot to write. Alright, so pi integral between 0 and 2 of 6 minus g of x, which is negative 2 plus 3 cosine pi over 2x. The whole thing is what's being squared, minus 6 minus f of x. Wait, f? That's h. Sorry. 6 minus 2x minus 1 squared. That parentheses there, that one is there, this one I have to close and square the whole thing. Now, it just tells us to write but do not evaluate, so we're fine. Honestly, this is going to be easier for them to read and understand and grade than if you fancied it up at all, tried to simplify it. So, yeah, leave it like that.